So yesterday we had done with the rate of the chemical reaction. Yesterday we had done with the rate of the chemical reaction, but the chemical reaction that we had chosen was a very simple one, rather the simplest form of the chemical reaction, where we had done with 1 mole of reactant is converted into 1 mole of product. I'm just recapping a little bit, and we got to the rate equation. Now you know what is average rate, what is instantaneous rate. Average rate is written in terms of delta and instantaneous rate is written in terms of d. Instantaneous rate means there is no time span, and average rate means it is measured within a time span. That we know. So I'm just writing anything. Suppose I'm writing the instantaneous rate. Okay, I'm writing the average rate. Okay, average rate average for this reaction we know equal to minus delta R, or delta concentration R, divided by delta T. Yes, in terms of reactant it is negative. Why in terms of reactant it is negative? Because in terms of reactant it is negative because the concentration of the reactant is decreasing with respect to time. And in terms of product it is positive, so it is equal to plus delta concentration of P by delta T. That we had seen. Clear? Now today the first thing we are going to know is that what is the unit for rate? Unit for rate. Very simple, you know already the dimensions and all, so you can very easily get it. Now rate, whether rate is average or instantaneous, it's nothing but the concentration unit. Delta concentration means what? The unit of concentration divided by the unit of time. So unit of rate is nothing but unit of concentration divided by unit of time. It's not that you have to remember, you must understand, you can automatically get it. It's the unit of concentration by unit of time. Unit of concentration is mole per liter, because generally the unit over here we are taking in molarity. The concentration of the solution, concentration in the reactant in case of aqueous phases, we are taking in molarity. So it is mole liter inverse, that's the unit of concentration, and time you know is second. So what is the unit of rate? Simple, that's the first point we must know. What is that? Mole liter inverse second inverse. Okay, mole liter inverse second inverse is the unit of rate or speed of a chemical reaction. It's nothing but the concentration divided by time. Okay, that's the first thing. The second thing, obviously, today what we are going to know is that, okay fine, we had discussed over here the simple reaction where 1 mole of reactant is converted into 1 mole of product. But we know that, no reaction, rather maybe almost no reaction are of this kind, right? Okay, almost no reaction are of this kind. So the general reaction, in general we can write down the reaction like this. Just let me write a general reaction and automatically you can understand that. A general reaction, suppose A moles of A is reacting with B moles of B, producing C moles of C and D moles of D. That's a general reaction. Okay, a general reaction I had written. Now for this general reaction, what is the rate expression? What is the rate of the reaction? So rate of the reaction in this case should be equal to, whenever we are calculating in terms of A, which is a reactant, there should be a negative sign. That concept we have already. Okay, so first we are writing the rate in terms of A. So that is minus delta concentration, okay, minus delta concentration A by delta T. But when we wrote this we wrote for only 1 mole of R. Now there are how many moles? A moles. So for A moles, this is the rate. For A moles, this is the rate. Okay. So for 1 mole, what is the rate? It is 1 by A. So whenever we are calculating the rate, we are calculating per mole. Okay. So that is why we have to divide it by the stoichiometric coefficients. That is the rate in terms of A, rate of the reaction in terms of A. Okay. Why the negative sign? You already know. Why the negative sign? Because A is a reactant. What will be the rate in terms of B? Same way we can write rate in terms of B is 1 by B, the stoichiometric coefficient of B into delta concentration B divided by delta T. Okay, fine. What is the rate with respect to C? C is now what? C is a product. So there won't be any negative sign, it will be only positive sign. So for C, it will be 1 by C, same thing, delta concentration of C divided by delta T. And for D, it will be plus 1 by D, delta concentration D divided by delta T. Now I am writing in the form of delta because I am talking of the average rate. If you are talking of the instantaneous rate, you may just write it in the form of differential form. Now all the rates, as I told yesterday, that now we are moving in a bus. Now they are all moving in a bus. There are so many passengers. Yesterday I told you are moving within my car. So if I ask you what is my speed, what is your speed, the speed is same. Same way, whether we are calculating the speed with respect to A or with respect to B or with respect to C or with respect to D, the rate is same. So these are all actually equal. These are all actually equal. So rate of the reaction with respect to A is this one. Rate of the rate with respect to B is this one. Rate of the reaction with respect to C is this one. Rate of the reaction with respect to D is this one. But this is nothing but, all these four terms are nothing but the rate of the reaction, which is constant for a particular reaction at a particular condition. Okay, so obviously they are all equal. Okay, that's the second or the third concept, whatever I told you today. Okay, so we are going to use these concepts in the numerical. We'll do that, but as I told before that, let me just finish the basic part of it today. Okay, if we can finish the basic part of it, then we can do very easily the remaining part. Next basic part is, now how can we find out the rate of a chemical reaction? How can we find out the rate of a chemical reaction? The sentence I am going to tell is very important and you are going to keep it in your mind. Always just put inside in your mind. The rate or the speed of a chemical reaction cannot be determined theoretically. It is a completely experimental quantity. We can find out the rate of a reaction only by doing the experiment with that particular reaction. We cannot say, we cannot predict the rate of the reaction by any theory. Though some theory had been proposed to explain the rate of the reaction, but that is absolutely not correct. But we must know that theory also, because in certain cases that particular theory is applicable. So while doing some numericals, we will also use that particular theory. What does that theory say? Suppose this is the question, this is the reaction, this is the reaction, again the general reaction I am saying. Okay, this is the reaction. Now what does this theory says? That is called rate law. We call it rate law. Okay, rate law. What is this rate law says? Rate law says that the rate of a chemical reaction, please understand it again, be very careful. Rate of a chemical reaction is directly proportional to the concentration of the reactants. So what are the reactants over here? A and B. Concentration of the reactants raised to some power, SOME, raised to some power. How much power? We don't know. Okay, we are writing it like this, to the power x to the power y. The mistakes the students are doing it is that they generally write it as to the power a and to the power b, because we have that habit of writing it from the equilibrium chapter. But no, if we know it is a and b, then we can predict it very easily. We can predict it very easily that what is the rate of the reaction theoretically only. But what the theory says, that the rate of a chemical reaction is directly proportional to the concentration of the reactants raised to some power. What is that power? We have to find out by doing the experiment. So we don't know. This x may be a. I am not saying it will never be a. It may be a, but it is not necessarily that it has to be a. Okay, y may be b, but it is not necessarily that it has to be b. Okay, so it is a completely experimentally determined quantity. Okay, so you can write this equal to, in general only I am writing, okay, this equal to k, some proportionality constant, into concentration A to the power x into concentration B to the power y. where this proportionality constant in the rate expression, this expression is called rate expression. Okay, in the rate expression, this proportionality constant is known as rate constant. I'm just introducing these terms. Tomorrow we are going to deal with these terms. Okay, as I told, the basic things. So what is rate law, or what does the rate law tells? Rate law tells that rate of a chemical reaction is directly proportional to the concentration of the reactants raised to some power. What power we cannot predict theoretically. Okay, we have to do the experiment, and by equating that we are getting a constant, proportionality constant, and that proportionality constant is known as rate constant. I'm just giving two examples. You can understand that. You can understand that very easily, that what is the meaning of this. For example, suppose a reaction I am writing over here is H2 plus Br2. Just no need of remembering this. Absolutely no need. You understood the concept, that is more than enough. Okay. H2 plus Br2 is producing twice HBr. Twice HBr. Okay. But is found experimentally, again experimentally, the rate of this reaction equal to K into, it is found, it is not done theoretically, into concentration H2 into concentration Br2. You see here the powers of H2 and Br2 is same as that of the stoichiometric, sorry, this is not Br2, this is I2, H2 plus I2, okay, H2 plus I2 equal to twice Hi, and the rate of the reaction is found to be equal to this. Fine. Then they tried the reaction, another reaction, H2 plus Br2 producing twice HBr. So if this would have been predicted theoretically, the rate of the reaction for the second case would have been K into concentration H2 into concentration Br2. But no, it is found something different. What it is found is, it's very complicated one that is found. So as I told once again that you don't have to remember this. It is found K into concentration H2 into concentration Br2 to the power half divided by concentration, K1 rather, divided by 1 plus K2 into concentration of H2 divided by HBr to the power 2. Okay, anything. Very, very complicated. So why did I write this to? Again I am saying no need of writing this even. You don't write it also. Okay. Why I had written these two particular equations? Two exactly similar equation. H2 plus I2 producing twice Hi and H2 plus Br2 producing twice HBr. Their rate expressions are completely different. That suggests what I said in the beginning, that rate of a chemical reaction is an experimentally determined quantity. It cannot be predicted from any theory. Okay, it cannot be predicted from any theory. Is it clear? Very good. Now I am going to write one more point, one more concept, and then we will move to the numerical. Just one more concept. So suppose this you know, this part you understood, that how to write down the reaction for a general reaction. So I'll just write a chemical reaction now, just specific chemical reaction I will just write. It is just anything, I can write it like this, whatever there in a book I am writing that only. 5 Br negative plus BrO3 negative plus BrO3 negative plus 6H positive plus 6H positive produces 3Br2, yes, and how many? 3H2O and 3H2O, yes, 3Br2 plus 3H2O. I hope I had written it correctly. Yes, 3Br2 plus 3H2O. Now this is a reaction that is given to you, and I told you write down the rate expression in terms of all reactants and products. I am writing it. Okay, I am writing rate of the reaction equal to, any doubt, anyone, please note it down. You will ask me afterwards. I am just writing it. Okay, minus 1 by 5. Obviously I am writing average rate, so I am writing delta concentration Br negative by delta T, that is in terms of Br negative, equal to what is in terms of BrO3 minus 1 by 1, the coefficient is 1. I'm just using this particular thing, this particular concept. Delta concentration of BrO3 negative divided by delta T equal to minus 1 by 6, right? Delta concentration H positive. Simple thing. Just one more concept I want to tell you, that is why I'm writing all these things, because you already know it. Equal to 1 by 3 delta Br2 delta T. Why did I write it plus? All of you understood that? Because that is product, and I end over here. Here comes the another concept. I didn't write anything with respect to water. I didn't write anything with respect to the water, which is one of the products over here. So the rate of a chemical reaction, if the reactant or the product is